Good morning, everybody. Hopefully you are having a great day today. Today is lesson 2, graphing systems of inequalities. Our learning target today is to be able to solve systems of inequalities by graphing. To review, an inequality is a dashed line if there's no or equals to sign. That means no line underneath it. It's going to be a solid line if it's a or equals to sign, which means there's a line underneath it. If we have a dashed line, that means if the dot is on that line, it does not count as part of our solution. So we would say, no, our boundary is not part of our solution. If we have a solid line, we would say, yes, our boundary is part of our solution because that is okay if our dot is in that portion. Our shading, if we have a greater than sign, it's going to be shaded above the line. So notice two greater than signs are shaded above the line. If it's a less than sign, it's going to be shaded below the graph. A system of inequalities is a set of two or more linear inequalities with the same variables. In order to graph a system of inequalities, you're going to follow these 3 steps. You're going to graph each inequality separately on the same coordinate plane. You'll lightly shade the solution region for each, and you're going to find where all shaded regions overlap and mark that spot more darkly. Let's look what that means in our examples. Here comes our first example. So we have y is less than or equal to 3. So we're going to treat this just like we did the other day when we did normal graphing. So the y-intercept, or the y-intercept on this problem is 0, 3. We have no x's in this problem, so our slope is going to be 0. Now, the next part I'm going to do is I'm going to use the inequality here. So our line should be solid because it has an or equals to sign. I used the chart from the page before. And we should be shading below the line because it is a less than sign. So let's go ahead and actually do that. So my y-intercept is 0, 3. My slope is 0. That means rise 1, run 0. So it's going to look like that. It's going to go forever in both directions. This is just graphing a line. Connect that in a solid line. And then we said it's going to be shaded below . So I simply just color in everything below that line. And I am good to go. Okay, now let's go ahead and do our next equation, which is not in slope-intercept form, so I need to make that happen. So the first thing I'm going to do is subtract x on both sides. So I would get y is greater than or equal to negative x plus 1. Now, my y-intercept on this problem is 0, 1. My slope is negative 1 over 1. This line is going to be it's going to be solid because it's a or equals to sign. And it's going to be shaded above. So let's go ahead and graph that. So I start at 0, 1, and I go down 1 over 1. So notice every time I'm just going down 1 over 1. I can go the opposite direction if I do the opposite thing. And then you can just make that a nice solid line. And we said this time it is going to be shaded above. So we'll go ahead and do that. Shade it above the line. And you'll notice they are overlapping in this little pizza slice area right here. So this is actually my solution area. I'm going to darken that in. My little pizza slice area is the overlapping region. So that is the solution region. What that means is if you put a dot there, both equations will be true at that point. Let's look at our next problem. I have the first equation right here. I'm going to subtract x on both sides first, so I have negative y is less than negative x plus 1. Sorry, that should be a negative 1. Okay. Now I am going to divide everything by negative 1. Now when I do that, make sure you flip your inequality because we are dividing our entire equation by a negative number. So I get y is greater than x plus 1. Now, I have it in slope-intercept form, so I'm good to go there. So I can go ahead and say that my y-intercept is 0, 1. My slope is 1 over 1. This thing is going to be a dashed line, and it's going to be shaded above. Okay, let's go ahead and graph that. So I start at 1, rise 1, run 1. Now we said it's going to be dashed. Just make a nice dashed line. And this time it's going to be shaded above. So we got something like that. Okay, let's look at our next equation. So we're going to have to subtract x on both sides to start. So I get negative y is greater than negative x plus 3. Divide everything by negative 1 to make that y positive. So I get y is less than x minus 3. So my y-intercept is 0, negative 3 based off that equation. My slope is 1, so it's going to be 1 over 1. It's going to be dashed, and it's going to be shaded below. So negative 3 is my y-intercept. My slope is still 1. And it's going to be dashed. We are shading below. Okay. And you'll notice that there is no overlap region, so we would say that they have no solution area. Next problem. Nice and easy, they're both in slope-intercept form, so we would say that our y-intercept is 0, 7. My slope is negative 1 over 3. This is going to be a dashed line, and it's going to be shaded below. Okay, so 0, 7, down 1 over 3. It's going to be dashed. And it is shaded below. Okay. Go ahead and do our next one. So we have our slope is 0, negative 3. I'm sorry, that's our y-intercept. Our slope is 4 over 1. It's going to be a solid line, and it's going to be shaded above. So 0, negative 3 is right there. I go up 4 over 1, up 4 over 1, up 4 over 1. I can do the same thing backwards. It's going to be solid. And then we're shading above. I always like to color the border of what the area is first. And you can see our overlap area gives us that nice purple. Okay. Let's look at our next example. It says Maria had a $150 gift card for iTunes, which she used to buy whole albums and movies. She bought fewer than 20 items. If each album cost $6 and each movie cost $9, how many of each item might she have bought? So the first thing that we have to do is write our equations. So it says Maria had $150 on a gift card. She bought albums and movies. So we know that the albums plus the movies had to be, and she bought 20 of them. So she bought less than 20 of them. But we also know that each album costs $6 plus movies cost $9, and she had to spend less than or equal to $150. So we have two separate equations we can do here. Here we have our albums plus our movies has to be less than 20. So let's label our graph here. Let's call this albums. Let's call this movies. So we know if she bought 0 movies, she could buy 20 albums. So if she bought 0 movies, she could buy 20 albums. On the other hand, if she bought 0 albums, she could buy 20 movies. That's based off our red circle right there, because we know she bought less than that. So it's going to be dashed. And then we have our other equation, which is going to be our blue equation. So if I bought 0 movies, I know that each album is $6. So if she bought 0 movies, let's pull out our calculator and do 150 divided by 6. So 25. So she could have bought 25 albums. We'll do the same thing for the movies. If she bought 0 albums, pull out our calculator. We'll do 150 divided by 9. So 16 would be the max she could buy. She can't buy something more. So 16 is going to be right around here. That's going to be a solid line. And that's going to be shaded below. And we actually forgot to shade our other one, which will also be shaded below. Okay, and in that overlap area, that's how many possible movies or albums she could buy. Have a great day.